Okay, so we've got another electromagnetics question here. We're told a 2 meter length of wire carrying 5 amps is at an angle of 30 degrees to a magnetic field of 50 microteslas. What is the force on the wire due to the field? And what is the size of the field required to give the same force if theta was equal to 45? Okay, so we have a formula for calculating force. We have force is equal to the length of the wire multiplied by the current in the wire multiplied by the magnitude of the field multiplied by sine of theta. This is where theta is the angle between the wire and the magnetic field. So for part A, we're told that theta is 30. We're told that L is 2 meters. We're told that I is 5 amps. We're told the field is 50 microteslas. So 50 microteslas converts to 5 times 10 to the minus 5 teslas. So we have F is equal to 2 times 5 times 5 times 10 to the minus 5 times sine of 30. So we can just put this in our calculator because this is physics, not maths. So 2 times 5 times 5 times 10 to the minus 5 times sine 30. My calculator tells me this is 2.5 times 10 to the minus 4. 2.5 times 10 to the minus 4. And this is in newtons. So this is the answer to part A. For part B, we're asked what is the size of the field required to give the same force if theta was 45? Well, if theta was 45, sine of 45 is larger than sine of 30. So we know immediately that the equivalent field required to produce the same force at the angle of 45 will be slightly weaker. And in fact, because the force in the case where the angle is 30 has to be equal to the force where the angle is 45, we find that L times I times the field times sine of 30 has to be equal to L times I times the field times sine of 45. Now L and I don't change, so they just cancel, and these fields are different, right, because we're asking for a different field strength. So we get B1 times sine of 30 is equal to B2 times sine of 45. Well, we know B1. B1 is the field strength that we just used, which is 5 times 10 to the minus 5. So to solve for B2, we divide both sides by sine of 45. Sine of 45, divide by sine of 45. This gives us that B2 is equal to B1 times sine of 30 over sine of 45. This is equal to 5 times 10 to the minus 5 times the ratio of sines. Sine of 30 over sine 45. We can put this in our calculator. This will tell us that B2 is 5 times 10 to the minus 5 times sine of 30 divided by sine of 45. And this is 3.535 ... times 10 to the minus 5. We could say that B2 is about 3.54 times 10 to the minus 5 teslas. And this is if we round this to, say, 2 decimal places. Depending on what you round it to, will depend on what your answer is. Your answer will change a little bit, but it's about 3.54 times 10 to the minus 5 teslas. And this is consistent with what we expected. We expected a slightly weaker field to produce the same force if the angle was greater. And the reason for this is if the angle was 0, there would be no force. If the angle was 90, there would be a maximal force. So as you increase the angle from 30 to 45, a fixed field strength will exert a greater force, right? So this answer is the correct answer in this case, but not only did we get it through calculation, we also confirmed that it is roughly consistent with what we should expect.